Okay, guys, I apologize for not having this made earlier, but this is 8.3. I did this on Monday or Tuesday and Wednesday after the quiz. So I wanted to go ahead and do this. The first warm up, I'm actually going to skip through it because I did in class. I will reuse that for another day. All right, so looking at number 2. First of all, starting with this, I do want to do this one because I want to show you how this works. So you take the square root of both sides. This is a review from yesterday, or the last time we were in class. So this gives you cosine of x is equal to plus or minus the square root. Remember, the square root of 1 over 4 means the square root of 1 over the square root of 4, and the square root of each of those are 1/2. And then you think about the unit circle. I have one down here. Where is cosine 1/2? Well, this is sine being 1/2. This is cosine being 1/2. So that's going to happen at pi over 6. And the other positive one would be pi over 3. Did I just write over 6? I'm so sorry. It's late at night, and I'm doing this after a long day. Late as in 8 o'clock. Pi over 3 and 5 pi over 3. And then if we look at the negative ones, because this says plus or minus 1/2, it's going to be these at 2 pi over 3 and 4 pi over 3. Now, if these aren't in order, it doesn't matter to me. I'll catch it. General solutions, what I want to do is point out to you that if you're looking at all of these solutions, I have one solution at pi over 3, which is up here, and I have a solution down here, which is 5 pi over 3, and then I have a solution up here that's at 2 pi over 3. And I have one, I'm sorry, this was 4 pi. I just caught it. And this one's going to be 5 pi over 3 because I was going to catch this one, write this one, and I go, wait a minute, 5 pi over 3 was already used. Okay, so what I pointed out in class is that if I am on these two, how far apart are these? And they are pi units apart, okay? So the general solution for this one, the first one is pi over 3 plus pi n being an integer. N is any integer, and an integer is positive or negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Positive and negative whole numbers, you could say, including 0. Integers. Sorry, I stopped writing to talk. All right, so this is the first one. There's one more general solution, and it's this. It's the one that's coming down this way, so it's 2 pi over 3 plus, how far is it to get to this side? Well, this distance is also pi units, okay? I'm not talking about the 3 pi over, y-axis there. I'm talking about the distance between this one and this one. They are pi units apart. So this is plus pi times n, and that takes care of all of them, okay? So let's go on. I'm going to stop. That's it, and I'm going to show you how you're going to use these. So if we look at x over 2, I'm going to scoot this up a little bit. If we look at where sine of x is 1/2, where does the sine function equal 1/2? If you look at this graphically, what happens here is that this line is where y is 1/2, and the curve, of course, is the sine. So this is your solution, this is your solution, and it comes in down here. So where is sine 1/2? Well, we already talked about where cosine is 1/2. Well, sine's 1/2 right here. So that's right here. And it also has a positive side over here as well, because sine is 1/2 right there. And I am looking at this side, not the other side. Okay, so if that's what I have, my two solutions, the two solutions here would be pi over 6 and 5 pi over 6. So if you know those, we're halfway there. So to find your general solutions, I'm putting GS for general, and this should not say general function. This should say solution. I messed that up. I would blame somebody else, but that would be me. Okay, general solutions are going to look like this. Okay, so you're going to have x equals pi over 6 and x equals 5 pi over 6. And then if you look at this, now what I'm going to show you is on this one, if I'm at this one and I want to get back to it, now notice this one is not one of the solutions. To get back to it, I have to add 2 pi before I hit another one that's in line with it. Now, this one is a solution, the one in quadrant 2, but I can't tell how many pi units away I am from there, okay? I am 1, 2, 3, 4. I'm 2/3 pi. Great, but I don't want every 2/3 pi another answer coming in. So I am just simply going to add 2 pi n. Now, if I do another one, let's take green. If I'm over here on this side, how far do I have to go before I come in line? Now, I don't go pi units. That would get me to here. There's not an answer there. I would have to loop all the way around, which is 2 pi again, instead of it being pi over 2, or just pi. So this is plus 2 pi n, where n is any integer, okay? So if n is 0, 0 times 2 pi, it will not move. It's going to be this answer, this front answer. If n becomes 1, then that means it's done a loop around it and it's coming back on it. Okay, enough said about that. Let's go on and see how this affects what we're working on. Okay, I actually want to see this. Actually, yeah, I want to keep it in line so I can see it. Now, what you have here is a graph. And again, we have a graph, and 2 pi over b is the period. So if we have, this is what I told in class, we have y equals a times sine of bx minus c plus d. This was from last semester. What we don't need is all of this stuff. I'm looking at just this right here. So what that's going to do, this b, this tells me how long the period is. So in this case, this is your b value, okay? So that means that if we have 2 pi over 1/2, and remember, keep, change, flip, 2 pi times 2 over 1, that would be 4 pi. And you're like, why are you showing me that? Because this number right here is 4 pi. And where this runs into the answer, it's not the same place as it was on the graph right up there. It's different answers. Watch what happens to these answers right here. Watch what happens to those. They are not going to be the same in this one because this did not finish its cycle at 2 pi right here. That is 2 pi. It didn't finish the whole cycle. It took 4 pi to finish. So it's going to change the values. Let's see how. So if we had sine of blob equals, let's call theta, let's say that theta is 1/2 x, okay? So then we have sine theta equals 1/2. Well, from up here, we know that's where x is equal to pi over 6 and 5 pi over 6. But it's not, oh, x, sorry, let's make that theta is equal to that. All right, so that's not what we have, though. We don't have theta equals that. If we did, we would be done. What we do have is theta is 1/2 x. So 1/2 x equals pi over 6 and 1/2 x equals 5 pi over 6. Now the reason I'm keeping it like this is that to get these answers, we have to be careful because we want all of our answers to be in the range of 0 to 2 pi, because that's the way we've done since we've started this unit. We're keeping them all the same just to keep it simple. All right, so I'm going to add, how often does this come up? Well, if I look back on my unit circle at pi over 6 and 5 pi over 6, look at what I had. Well, let's just use what I had right here. So plus 2 pi n plus 2 pi n. All right, well, we would be done if these were x's. These aren't x's. These are 1/2 x's right here. So how do I change 1/2 into 1x? I multiply it by 2 over 1. And what I do to one side of an equation, here's the equals, I have to do to the other side, times 2 times 2. And this one, 2 over 1, 2 over 1. You may want to put that over 1 because you're next to a fraction, times 2. Guys, please be careful with these fractions. Do not multiply the 2 times the top and the bottom. That's incorrect. It's 2 over 1. All right, so what cleans up in this and what's our answer look like? This cancels, x equals, oh, this cancels and becomes a 2. Pi over 2 plus 4 pi n. This one becomes x equals, this reduces to a 3, 5 pi over 3 plus 4 pi n. Okay, these two in black are my general solutions. So what are my solutions from the unit circle? Those solutions, actually, let me get a highlighter. Those solutions are only going to be my pi over 2 and my 5 pi over, that should have been I multiplied by 3. I multiplied by 2. 2 goes into, that looked like a 3 because I underlined it. I've got to go back and fix this. I'm so sorry. Let's fix it. There. This needs to be a 3 because that's a 2 goes into 6 3 times. I misread it. My apologies. Okay, so this is pi over 3, okay, and 5 pi over 3. They have to have the same denominator. Okay, so my final solution, if I were to add any pi, 4 pi, if I were to add 4 pi because n is something other than 1, then it would be bigger than 2 pi, right? 4 pi is bigger than 2 pi. So if I added a 4 pi right now, if from here, if n equals 0, x equals pi over 3. This is one of the answers. So what if we let n equal 1? What would x be? It's 4 pi plus pi over 3, which is greater than 2 pi, right? Because we're at 4 pi, so we can't count this answer. This is no. No. Get rid of them, okay? All right, so look at the bottom one. Let's do that one. I'll do it in blue. So right here, so for n equal 0, x equals, okay, all of this goes away if it's 0. All right, so it's equal to 5 pi over 3. Done. There's my two answers, here and here. So I have general solutions and I have those answers. So let's do a couple of these together and we'll see how quickly we can get through. I am going to leave the last one off because I think it's just too difficult. So let's go with the ones that I have right here. So first thing I want to do is get cosine of this blob by itself. So I'm going to divide by 2 and that cancels. So cosine of 1/3 x, I am not going to substitute this again, is 1/2. So where is cosine 1/2? So we need to look at a unit circle. And we have a half. Cosine's the first one, so that's up at pi over 3. Pi over 3, sorry, it's not too straight. And then where else is it positive 1/2? Down here at 5 pi over 3. So that's going to be, my answer is going to be, and notice they don't make 180 degrees across from each other. In fact, those are really bad. So this is going to be at pi over 3 and 1/3 x at 5 pi over 3. Now, these could be your answers, but I'm not done with x. So what would the general solutions look like? Plus 2 pi n plus 2 pi n. Now, if you're sitting here thinking, all right, Miss B, why did we do 2 pi n instead of pi n? Look, guys, we did not have a solution to come out with a lovely diagonal. If they're not a diagonal, we use 2 pi because you've got to get back to this one that you want to find it over and over and over again, like in different cycles, all the way down the cycle, right? Okay, so this is what we do. So I'm going to multiply each side by 3. And when you multiply by 3, you multiply every part. This time it is a 3 by 3, 3, 3. And this is why I have to multiply by 3, because it's 3 over 1. The 3's cancel. X is equal to, oh, those cancel, pi plus 6 pi n. All right, so first answer of just, these are my general solutions, all right? Right here. This is a general solution, and I want to know that. Okay, but what is x equal to between 0 and 2 pi? Well, right here it says it's equal to pi. Because if n goes to 0, this 6 pi is gone, and I'm left with just pi. Here, this cancels, and that becomes 6. So x equals 5 pi plus 6n, just like above, the 6 pi n, 6 pi n. Let's turn that into a pi. And according to this, when n is 0, x is equal to 5 pi. Okay? Now, there's a problem. 5 pi is too big. So that means I can't use that one. This is my only answer. Okay? Let's look at number 2. All right, so I'm going to do it like I did before. I'm going to divide. Oh, wait, there's a minus sign. I have to move that first, plus 3. I did see some people on the quiz move some things first that should not have been moved first. So 3 tangent equals 3 tangent. I kind of just left out everything there. Let's fix that. Tangent x over 4 equals 3. Divide by 3. And we get 1. Now, tangent is a special bird. Tangent of x over 4 equals 1. What's cool about tangent? Now, we should all know where it's 1. It's 1 at this pi over 4 at 45 degrees. And it's also positive down here at 5 pi over 4. Yeah, that's the right number. And how far apart is it from here to here? This is pi units. So this is one of those special ones. So the answer is going to be x over 4 equals pi over 4 plus pi n. Now when I add pi n, when n is 1, it's going to put me right here when n equals 1 over here. Okay? Because that means I'm adding pi, and this is a plus pi situation. All right, so the last thing I need to do is just multiply by 4. And when I multiply by 4, I'm multiplying all parts by 4. If you need the fraction over 1, by all means do so. X is equal to pi plus 4 pi n, and I'm done. Now remember, whatever's right here is going to be one of our solutions, pi, as long as it fits between 0 and 2 pi. Okay, so x equals pi. And is there anything else? Well, if we let n equal 1, then what we have, x is equal to pi plus 4 pi times 1, which is 4 pi, that's 5 pi. And that's too big. Not allowed to have it. It's over 2 pi. Just kidding, right? Okay, let's look at the next one. All right, this is the last one I'm going to do, so you can try some homework. And I'm going to take this and solve it. I feel blue. All right, so I'm going to divide by 5. So I get secant of 1/4 x equals 2. And then that means I've got a secant. Oh, I can't have just secant. I've got to have 1 over cosine of 1/4 x. And the x doesn't go to the bottom. My apologies. It should be up beside it. Equals 2 over 1. So now I'm going to flip them, and this becomes 1 over cosine. I'm sorry, I did not flip it. Okay, this becomes cosine. I'm going to correct the way I wrote that. 1/4 x, that's the way it should be, equals, this should have been 2 over 1. Let's flip it, make it 1/2. My apologies. Okay, so let's see, where is cosine 1/2? So that's where the 1/2 comes first. That's up here at pi over 3. And down here at 5 pi over 3, I think that's where my brain was going, 5 pi over 3. So that means from here, I have 2 answers. So 1/4 x, and notice they're not pi distance apart. 1/4 x equals, I said, pi over 3. Since I'm not doing this one, I can run into that broom. So plus 2 pi n and 1/4 x equals, what did I say, 5 pi over 3? 5 pi over 3 plus 2 pi n. All right, I just like taking another color to point out the reason this is not going to be plus pi n, because I didn't get to go to there and stop. It's going to have to find another time for it to hit here is going to have to be right there. So that takes a plus 2 pi, not plus pi. That's the reason why we have this. Now, I haven't solved for x, so I've got to multiply every side and every piece by 4. Okay, if you need the 4 over 1 to cancel, by all means do 4 over 1. X is equal to 4 pi over 3 plus, holy mackerel, this multiplies 8 pi n. Now, if I'm going to add 8 pi, don't you think it's going to be bigger than 2 pi? Yes. So the only answer I am going to get is when n is 0, and so x is equal to 4 pi over 3. All right? So over here, I'm going to multiply both sides. I'm going to change colors just to make it a little different. Multiply by 4 over 1, 4 over 1, 4 over 1. I didn't need the over 1 on this one. Got carried away. Those cancel, and I have x is equal to, holy cow, 20 pi over 3 plus 8 pi n. Now, usually this is one of our possible answers. But guys, 20 pi over 3, 3 goes into 20 almost 7 times. This is bigger than 6 pi. Greater than 6 pi. This thing right here is greater than 6 pi. If that's greater than 6 pi, it won't fit between 0 and 2 pi. Okay? So this is my only answer, and this one does not count. I will do a yellow on top of it. Does not count. Okay? Although our general solution, that is correct. In fact, let me undo that. I can do it like this. 20, whoops, in the process of that, I lost my over 3. 20 over 3 pi does not count. Okay? We can't use it because it doesn't fit here. All right, I'm done. Sorry. Too long.